Okay, so I'm gonna try to recreate what I did earlier today, and do it a little bit quicker. The video that I made earlier was like 35 minutes, so hopefully part of doing this is that um, it will be quicker. Okay, so we have these are poverty rates. Um, I have give me a second. This is the percent of families below the poverty level. Um, just so that we kind of know what we're looking at. All right, so we have a set of things that we should um kind of first consider or think about um when we are starting a classification. So one, we want to know what are these enumeration units. So if we look, we can see that it's mostly states, and then I see District of Columbia and Puerto Rico. So it's US states, Puerto Rico, and DC. And often this makes a lot of sense, right? Oftentimes we kind of count Puerto Rico along with states, uh, depending on what kind of thing we're mapping out. Um, and I'm really sorry, it's like pretty late for me, so I might not be the most eloquent right now. Um, but anyways, a lot of times we often map Puerto Rico when we're mapping out census data along with the states. And the same with DC. However, we can immediately see here that Puerto Rico is an extreme outlier. Um, that's more than double the next highest percent, um, which is it's just what that's showing, right, is extreme poverty in Puerto Rico um, compared to the rest of the United States. So just something to kind of keep in mind, and we'll come back to this kind of extreme outlier here. Um, this was originally in the data set, but I will just tell you real quick that 8.7 is the United States average. So if we were looking at an average across all of the US, so this kind of goes into that modifiable area unit problem. Like if we just consider the United States as one giant polygon, if we were to get the value for that, it would be 8.7, which we can see would fall right in here. So basically from California and below, these are states that have less than the US average, and the ones up from Michigan and above have more than the US average. Okay, does that make sense here? So California has 8.4, our average is 8.7 for the entire US, and Michigan is 8.8, and everything else here is higher. Okay. Next we want to think about how many classes, anywhere from say 3 to 8 or 9 is fine. Gonna just pick 5 because that is a good amount of different colors to be able to see differences between. So that's what I'm gonna pick. And then how many data values are there? So I can tell you right now how many states are there. There are 50 states in the United States. Then we have Puerto Rico and DC. So we have 52 data points in our data set here. So I'm just gonna make a nice little border there for our kind of like important info to keep in mind. All right, so now we want to look at let's do a quantile classification scheme. Quantile classification scheme. And so how do we do that? We take this is really simple math. We take our number of data points divided by our number of classes, okay? And we end up with 10.4. So then to go and do that, I'm going to start, for me, I'm going to start at the bottom. It doesn't really matter, but I'm going to start at the bottom and count 10. Now, I know because I have 52 and I have 5 classes that I've got kind of like 10 with a remainder of 2 if I divided this out and didn't have a decimal point. So I know that I've kind of got this wiggle room of 2 extra data points that I can mess around with. So I'll show you what that kind of looks like here. So, all right, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in theory, these 10 would definitely be in that first quantile. But what you will see is that Wisconsin and Massachusetts here have the same value, 6.6. So to make this make sense, let's obviously throw in Massachusetts into that first class. So this is our class 1. And there are 11 data points here. All right. So next class, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I end up with the same issue where Montana and Wyoming have the same percent. So let's put 11 data points in this one as well. And then let's give that the next color up. Class 2, 11 data points. All right. So now, if I take out the rest of, think about how many data points I have left. I have 30 data points left and 3 classes. So I don't have kind of any more wiggle room in the number of data points per class. So the rest of the classes need to have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let's merge those, give them the next color. Class 3 is 10 data points. All right, and then same thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Merge those. And then this is class 4. This is 10 data points. And then our last one, which is class 5, 10 data points. And I need to merge it. Okay. So now I have my quantile classification scheme where I had 11 in the first two classes to avoid having a break where I have the same values, and then the other three have just 10 data points. What we'll get in our result is a really, really balanced map. But what we also see is that, say, in this last class, we've got a range from 10.7 all the way up to our extreme outlier of Puerto Rico and of 38.2. And so we're really lumping like a large range there into that last class. Yeah, so just something to kind of consider there. Um, but it does give you a really balanced looking map. All right, now let's do equal interval, which is not necessarily more difficult, but um it's less counting, I guess. It's a little more adding. All right, so first we need to decide what our range is. So our range is take the largest number, subtract the smallest number here, and there's our range, 33.8. Then we want to get our interval, and our interval is our range divided by the number of classes. Okay. So in this case, it's 33.8 divided by 5. Okay. So we get an interval of 6.76. Then let's kind of pull this out into something that we can look at really easily. All right, so we want to find out what is our low value is going to be that lowest value in our data set. And then to get our high value in class 1, it's going to be that low value plus our interval. Okay. And then for our low value for class 2, we can do this, our high value plus, and let's say 0.01. Okay, just so we have a little bit of incremental increase here. And then for our high value, it's going to be that low value plus our interval. And we can drag that down. And then this plus our interval. Drag this down. This plus our interval. And then once more, low value plus our interval. Okay? So that's going to give us our legend here. Okay? So class 1 is 4.4 to 11.16. And we could, yeah, no, let's just leave it like that. I'm not gonna kind of dig into this. Now, when we go to do this over here, let's look at this. All right, so our low value It's 4.4 all the way up to 11.16. So that puts 11.16, and that takes us through Oklahoma. Okay. Let's merge those. What we end up with is class 1 is 44 data points. Meaning, in our, remember we had 52 total. 44 of them are just in one class when we do an equal interval, okay? Because it's not really considering what the distribution is within that data set, it's just considering the range, okay? It's just considering that top value and the bottom value and dividing evenly, okay? So it's not considering the any sort of distribution aspects in your data set. Okay, so then what does that give us? From 11.17 to 17.93. So our next class is everything except for Puerto Rico. So class 2. And that is 7 data points. And then, so I'm going to write this down over here, 44 data points, 7 data points. And then we have 0 data points. Sorry, that says 9. 0 data points in class 3, 0 data points in class 4, and 1 data point in class 5. All right, so class 5 here is 1 data point. So we end up with these 2 empty classes. Okay, so it's just something that is kind of commonly occur with equal interval is that you end up with these empty classes because it's only considering the range, it is not considering the distribution that's happening in there. And so extreme outliers, like in this example, this is totally real data, poverty rate data, that's aggregated across several years from 2019 to 2023. And so anyways, you can just see that in real data, we end up with extreme outliers like this. Okay, so what's a way in which to deal with this? So I think let's try kind of an equal interval where we just automatically put Puerto Rico in class 5 by itself, but we then use equal interval for kind of the smaller range that excludes Puerto Rico. So let's call this manual, but it's going to be based on equal interval, but with the goal of reducing empty classes caused by the extreme outlier. All right. And then, so let's think about what our range is here. So let's ignore Puerto Rico for the moment because of kind of it being an extreme outlier here. So if we look at the range of from our lowest number, so 4.4, and then subtract, oops, let's do from our highest value except Puerto Rico minus our lowest value. Sorry, hopefully you understood what I was doing there. So, I didn't want to end up with a negative number. We could have just done the absolute value of that number. But anyways, I just want to get the range, which is the highest number minus the lowest number. But in our case, right, in the first one, when we included Puerto Rico, that range is 33.8. When we exclude Puerto Rico, our range comes down to 9.9. And then so let's find out our interval for this. So we're still going to have 5 classes, but because we've excluded Puerto Rico, and we know that Puerto Rico is going to go in that 5th class by itself, we're going to kind of consider that the number of classes in this manual data classification is going to be just 4 with this smaller range. Okay, so my range is 9.9, and then I'm going to divide that by 4. Okay, so I end up with a interval of 2.475, and I want to reduce the number of digits here because I feel like it's going to cause me some problems. Okay, so now let's do this. We're going to do same thing that we did here. Actually, I can probably even do this. Nope, didn't work. All right, our low value is that. And then it's our low value plus our interval. Um, I'm having some rounding errors, and honestly, I'm like too tired to think about what's causing this. I know that it's the number of significant digits in this interval that Excel is like hiding from me by me trying to reduce the number of significant digits. But anyways, I'm honestly a little bit too tired to figure it out. But so ignore my minor math problems here. Yeah, see, I'm having issues because it's trying to reduce that. Whatever. Okay. Anyways, I take my low value, I add my interval, gives me my high value. Um, And then I end up with 14.3 being the top value of inclusion in my last uh my class 4. And then this last one is just my highest number. So okay. So what do I end up with here now? All right, let's look at this in color. All right, so I have 4.4 to 6.9. So that takes me through Hawaii is in class 1. Class 2 is 6, is like the next piece, 7 through 9.4, North Carolina. Yep. And then New York through 11.8, Kentucky. And then we've got this kind of small class here. And then finally, our extreme outlier of class 5. So class 4 has, what is it, 4 data points? All right. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Class 3, 10 data points. And you don't normally have to do this. You don't need to like count these normally. I just am doing it because I think I want to just kind of show you what this looks like, I guess. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20. Merge class 2. It's 20 data points. And then 1, 2. How many are left? 10, 30, 34, 35. So this is 15, I think. Oh, no, it's like 18. Class 1, 18. I think. Might be 17. Sorry, it's late for me. Okay. So anyways, what you can see is that by kind of using equal interval, but taking into consideration the actual data set, we were able to make a bit of a better classification scheme. that accounted for this extreme outlier of Puerto Rico. We also avoided this empty class situation. Because that's just going to be weird. Like this map here is just going to show, I mean, what it is going to really show you is that Puerto Rico is really an extreme outlier, which is true. I mean, compared to the next value, it's more than double, which is really insane when you're talking about poverty, especially. So it's just something that you might want to show. Um, to your map readers. But there's also some problems with it, right? With the empty classes is confusing, and that kind of thing. So this other equal interval classification scheme might be it's a better way to go. But what ArcGIS would consider this to be is a manual classification scheme. It's based on an equal interval classification scheme, but it ultimately isn't just kind of taking that range and dividing it evenly. Okay. Um, and we can also say that there's some problems too um with quantile. It's going to give us a really balanced looking map, but it's lumping in um DC that has that where like only about 10% of families are below the poverty level compared to more than 2/3 of families are below the poverty level in Puerto Rico, and that's all in the same class. So in that way, we could be kind of masking some of the things that are actually going on. So ultimately, my goal for you for the quiz is to be able to understand how to do the kind of basic equal interval and quantile. But what I want you to be able to do for your lab and just generally as you're thinking about data classification in the future is to really consider that you play around with how the map looks, what your distribution looks like, what makes sense, what makes a legend that's understandable, that kind of thing. And there's a lot of considerations to kind of take into account. But I want you to understand the math of equal interval and quantile so that you can deviate from them. It's like the saying of like, once you know all the rules, then you can break them. That's what I want you to understand. Like, I want you to know what the rule is because I want you to break it, but I need you to understand like how this is calculated, how this is figured out, that kind of thing. And hopefully at 10 o'clock on Halloween night on Friday, that all made sense. And please let me know if it didn't, and I'm happy to elaborate for you guys. So enjoy.